This is day 2 of our video notes that go with our guided notes for laws of exponents. So let's slide down to our third little part right here. Now, on this law today, we're going to explore powers of a power. Now, remember the word power means exponent. Okay, or an exponent means you're carrying a base number or variable to a power. Okay, so if I look at my law right here, it will say a to the m power inside the parentheses, and then I'm going to raise it to the n power. Okay, now again, typically when I'm talking about laws of exponents, they use lowercase a's, and they'll use m's and n's to represent your exponents, okay? So our law says if I have a base of a raised to 1 power m, then raised to a second power n, what I'm going to do is take those two exponents and multiply those together. Well, Wes, why is that true? Okay, so let's just explore for a minute. Again, we're going to look, listen, digest, and not write this down. Okay, so let's explore something like, let's say x to the 4th power. Okay, and I'm going to put that in parentheses, and I'm going to raise that to the 3rd power. What is that telling me? What does that expression really tell me? Well, first of all, let's look at this 3 outside the parentheses. That means I'm going to take 3 of these, and multiply together. So what that's telling me is x to the 4th times x to the 4th times x to the 4th. Okay, so do you see the 3? Here's the first one, there's the second one, and there's the 3rd one. Okay, so that's what this 3 means. Now let's talk about these x's to the 4th. What does each one of those mean? It means to take 4 x's and multiply together. So this first one right here is going to be x times x times x times x. This middle one right here is x times x times x times x. Well, what's this 3rd one over here? X times x times x times x. Now, what is in between those? They're multiply, right? So multiply. So that's what all of this means, expanded, okay? I've expanded this expression where my finger's bopping up and down to this. Well, if I start counting all my x's, because everything here is multiply. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that means I'm multiplying 12 x's together, or that's x to the 12. Now, again, the same smarty pants that figured out the other day, they could add the exponents. What did they notice with the 4 and the 3? Well, what's 4 times 3? 12. Okay. Now, remember the other day I told you laws of exponents is a way to shortcut all this expanding and still be able to show good quality work that everybody knows what you're doing. Now, when I was your age and I was learning this, this is what my teacher showed me. If you block off that X, what do you really see? I see 4 in the parentheses, 3 outside the parentheses. Don't that look like 4 times 3? Does it not look like 4 times 3? So that was one way I used to help remember that that's what I needed to do there, because I really could see that the exponents are being multiplied right here. Okay? Now, let's apply what we just talked about here into 4 examples. Okay? We'll look right here, x to the 3rd raised to the 2nd power, or we could say x cubed squared. Okay? Different ways to say it, but to show the work, I'm going to say x, and then I'm going to do 3 times 2, and I'm going to make sure that I'm writing big enough But you can see one, that the 3 and the 2 are exponents, and that the dot is a multiply, not a decimal. Okay, so that's going to give me x to the 6th power. Okay, and I'm done. Oh, that's not too bad. Now, look at number 10. 10 is actually, again, the 8th grade version of this because it has a number base instead of a variable base. But remember, when we're doing laws of exponents, we never change the base. The base will always stay the same, so it's 8. All I'm going to mess with the laws of exponents are the exponents. Okay, so that's going to give me 7 times 4, or that's equivalent to 8, and then 7 times 4 is 28. So 8 to the 28th power. Oh, that's a big number. I'm glad I'm not going to have to multiply all that out. Okay. Now, 11, just like the third example earlier yesterday, we're doing this with more than one variable. So inside the parentheses, I've got an x, a y, and a z. Okay, and they each have their own exponent. Then I've got the squared outside the parentheses. So really what you're going to think about here is almost like the distributive property. See the squared outside? I got to apply it to the x, I got to apply it to the y, and I've also got to apply it to the z. Okay, so I'm really going to do this little law of exponents 3 times, once with the x, once with the y, and once with the z. So what is that going to look like? Well, let's just start right here with the x. Multiply the x exponent, I'm going to say that 5 times 5, x exponent, 3, and the 2. So I've got x to the 3 times 2 power. Then I'm going to come right here and I'm going to do my y. The y exponent is 4 and 2. So that's 4 times 2 power. Then I've got my z. Well, the exponent on my z is 6. So that's going to be 6 times 2. Now, let's simplify this. So, x, and then 3 times 2 is 6, so x to the 6. On my y is 4 times 2, which is 8. And on the z, it is 6 times 2, which is 12. So my final answer is x to the 6, y to the 8, z to the 12. Okay? Now, number 12, yeah, I got the x and the y, so I've got 2 variables, but this time I added in my coefficient too. Okay, now I'm still going to have to think right here, distributive. So this third power goes with the 2. It's going to go with my x, and it's also going to go with my y. Okay, now let's look at how we're going to do this. My 2 right here, that's actually 2 to the 3rd power. Okay, because if I ignore the x and the y, that's really what I got, just 2 to the 3rd power. Now my x right here has a 1 exponent, because remember, we don't see an exponent right there. So we got x, and then we got 1 times 3. Then on the y, same thing we did before, 6 times 3. Now let's simplify. Now 2 to the 3rd power, we can do that. 2 times 2 times 2, that's 8. And then that's going to be x to the 3rd power, because 1 times 3 is 3. And then y to the 6 times 3, which is 18. So my answer here is 8x to the 3rd, y to the 18th. Now, y'all, go ahead and make sure you've got these notes copied down in your interactive notebook, and then work on your assignment in Canvas.